we are still on the topic of static characteristics, but we're going to go into input loading. So input loading is a very important concept. Okay, the input impedance of an instrument is the load that the instrument imposes on the source signal. What does it mean? It means if the source signal right here were to look into the measurement system here, you will see a little resistor there or resistance there. So it's always present because the current drawn has to be drawn into the measuring system. Okay, and then back and then back. So the current will have to go through here. It has to go through this resistor in order to get some voltages or something, so that you can get a measurement here. So it is always present. So this is very important. So when the measured voltage is lower than the source voltage because of the potential divider circuit form, so you can see that is a RS, which is the source here, okay, and a R in, which is our input impedance, and we are actually just measuring this part. So we are measuring here. Okay, so this resistance would actually have some voltage which you measure. So this resistance will actually affect the whole thing. Okay, so to minimize this measurement error, okay, the input impedance has to be very high compared to your source resistance, which is given here, which means the resistance that your source. So what we want is your R in to be very high, okay, and your R out from your other system has to be lower. Your R out or your RS source for that matter. So this is very important. That will be part of your exercise later on. When we're talking about the input, we also have to talk about this thing called the input range, okay, which means the range of values, okay, that the measurement instrument can measure, okay. There is no instrument in this world that is able to measure infinitely, okay, which means the range cannot be from positive, negative, infinity to negative infinity. There is no such thing, okay, no such measurement system, okay. Hence we have to actually limit a input range. A very simple example, a measuring tape, okay, a measuring tape that looks like this, okay, can it measure infinite length? No, because we are limited by the. So your measuring tape does not measure infinitely or negative infinitely for that matter. So it has a range, okay. Normally you have 5 meters or to a maximum of 3 meters. That is your input range for that method. Okay. Another example that is quoted here is a oscilloscope. So it has a measurement bandwidth of 100 megahertz. Okay, and it cannot display a 1 volt peak-to-peak sine wave of measured amplitude of 1 volt. Instead, it will give a much lower. It might give a much lower peak-to-peak, right? Because of the Another thing is the mobile voltmeter. If you try to measure a high voltage, you will damage the voltmeter. For example, this one can measure, um, say, 50 volts, but you gave an input of 100 volts. Then what will happen? Your fuse will be blown. Okay, NK damage. Yeah. So that is